That's cool.
But I'm at Alpha Tuesdays, Thursdays, all day.
Seeing people.
Yeah.
What's the average age of your clients?
Oh, kids.
Oh, kids.
Yeah, except I'm getting a lady, they're giving me one because nobody
Take her.
will take her because she doesn't have insurance and they don't want to, no one goes.
There's your practicum. Yeah, we do the same thing. And you have to.
They asked her if she'd be okay with it. She said, I'm supposed to be teaching her parenting skills for, I was like, well, how old is her child? They're like, a teen. Oh, boy. Which is funny though, because I actually just finished the book on, you have more pictures of me.
Oh yeah. This is.
He was a little bitty.
He was a little bitty.
I don't, what's funny is I look back at Carson's pictures and that he's changed so much, but they haven't changed so much. I mean,
Yeah.
there's pictures of him, obviously, he still looks like the same person, but gosh, they just grow so fast, don't they? It's unbelievable. Unbelievable. It doesn't seem like that long ago, and yet, come
Almost
May, it's gonna be 2 years.
June for June.
What's the date?
June 15th.
15th, okay. Because Nora's is the 18th.
Nora's a cute name. Hey, nice. How many hours are you taking?
This semester I'm taking 12,
Okay.
and it's my last semester actually, so I'm excited about that.
Pretty full. Okay, pretty full caseload. So you and Lauren are walking
May.
in May.
Yeah.
All right. That's awesome. That's a good feeling.
Yeah, it is. It is.
Are you going to go straight into medical school from your master's program here?
Not yet, because I'm an international student, and our admission to medical school is way, way different than that of American students. It's a lot of paperwork and a lot of state paperwork and just other things. So I'm trying to take care of all those things first before I can go in. So, and usually it's a process. It takes quite some time. So it won't be straight from Alva to Norman. I will still have to wait until all the paperwork are taken care of in terms of the state level and even the national level, and then I can be enrolled and start. So I'm looking forward to medical school in 2015.
Okay. Okay. Good.
Yeah. Yeah.
Well, I hope that I give you plenty of material to help down the road. I try to take a holistic look at things, so hopefully it will help.
Yeah. Yeah, thank you so much. I'm excited about that. So all the help that I can get will really make a difference. So yeah.
Cool.
Yeah.
So you may not take the counselor exam, or you might think about taking the counselor exam after school.
I'm looking into all that because even with that, it's not open to international students. You have to have the green card
Oh, okay.
for the residency.
Oh yeah, that's
all
right.
That.
Okay.
Yeah.
Okay.
Yeah, and all those things I'm gonna be taking care of them this year. So I don't know what I'm gonna do yet, but while I'm taking care of all those processes, I may just try to relax and get ready for the next year.
Okay. Nice.
Yeah.
What is your country of origin?
I try to think of myself as a divine being.
Okay.
I'm a very spiritual person, so every time I get to be asked, where are you from? I tell them I'm from heaven. It's just Africa, and Congo was my point of entry to the world. So.
All right, I like that answer. I like that answer a lot. My,
Yeah.
I have a second master's in theology, so
Wow.
it's from a Christian perspective, but it was a very I would say more liberal and informed way of looking, using like an evidence-based understanding of Christianity, and especially the way it relates to other cultures. Not trying to change them, but accepting other people for who they are, and not trying to impose any belief system whatsoever, but trying to learn from other people and their belief system. So that's what
That's pretty important in this line of work.
that's what my theology goes towards, is learning from others. So I appreciate any perspective.
Thank you.
With continuing on, I'm gonna say the same thing in a different way. What's this little guy here who happens to be my son? When he was 19 months ago, laying there in that bed, what is he capable of?
Just breathing.
Yes, he's breathing.
And crying.
Letting
Yes.
you do basics, pretty much.
Yes,
And
he-
eating, pooping. I guess that's pretty much what they all
Even
cover.
sleeping, pooping, crying, letting you know he needs his basics, his basic needs met. But
Yeah.
also, I mean, then they also have all those different. I can't remember parts.
that's okay.
The reflexes they have that
Yeah,
you
the
know,
basic
don't
reflexes.
exist anymore. Well,
Rooting
as you get
reflexes,
older,
grasping reflex. Can't all those little fancy pictures with baby hands. You can't get a picture of a baby hand because
No.
their hands grasp up when anything
I still
touches
can't
them.
get a picture of
You can,
it.
that's why they get footprints. So yeah, he's got what part of his brain is wired up? Which part of this brain is wired up, ready to go? It's that one down there. The basic stuff is there. He can't walk, he can't talk, he can't tell you what's on his mind. He can't decide which bills to pay when, which car to drive. All those things that we take for granted when we're adults that just happen naturally, seem to happen naturally, are stuff that he is learning, that he is going to have to learn over the years. So this part of the brain is wired up. This part of the brain is full of cells, but they're not necessarily connected together. So again, I won't go through what we just went through. The way that I like to understand a developing brain is like a tree. And so if you have a little sapling here, which would represent Jansen at 1 week, you have a few major branches coming off, heartbeat, breathing, some reflexes in there, some biological function of digestion and elimination, some basic stuff, but there's all this waiting for experience and exposure and stimulation to start helping this tree branch out and grow into this neural network that then helps us become an adult human. And so if we go through a healthy development without periods of extreme stress or extreme duress or substance use, early substance use, one of the big things that I noticed at the rehab when I would work with an adult 35, 40 years old, and they're presenting to me with the emotional, affect, the social ability of someone in junior high. Well, you know what she did? And then I was going to go up and I was going to slap her. And it's like, okay, well, you are 35 years old, so what is that going to do? My motivational interview going on there. So, actually, that would be reality therapy. But anyway, you have people that become somewhat stunted in their growth with early substance use. But I want us to kind of understand that brain development, that neurological development, and what can happen if folks start to, and you know, kids that grow up in families with addiction, like the case study we just looked at there. How often were the emotional, physical, you know, needs of that child that was taken away being met by the 34-year-old alcoholic mother? We don't know, we didn't know, but there's a chance that there's some significant maladaptation, especially since DHS had enough information to take custody of the child. So we want to look at how our brain is growing. What do you notice about the kittens in the photo?
Yeah, babies.
They are little kittens. What, anything else?
They seem to be cozy.
Yeah, they do look cozy. Just want to hold them. So,
Other than that, they don't have any other senses, the eyes, and I don't think they can even hear at that point.
there, your eyes. Yes, you notice about the eyes. Can little kittens and puppies, can little humans see real well when they're first born? No, 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 no. Kittens cannot see you. Their eyes are closed. And so there was a researcher that was looking at neural development in cats in the 50s. And so what the researcher decided to do, he postulated, you know, I think that there's a critical period in the visual development of cats that they have to have stimulation on their eyes between 7 and 11 days of birth, after, you know, 7 of 11 days of life, for them to develop sight. So what the researcher did is he impaired the vision of a group of cats in the experimental group, kittens, and he allowed the control group to obviously develop normally. And so for every kitten that he patched the eyes, did not allow light to the eyes of the kittens between 7 and 11 days, none of those cats ever had the ability to see. And so what does that tell you about that critical period?
But if you miss the window, you're not going to get that back.
Exactly. If you miss the window, you're not going to get that back. So for lifelong, the kittens were blind. And so we have the same thing in our brain. And when you look at human development, it really relates to bonding. And so when we're thinking about addiction and human development, not only do some of these critical periods extend into adolescence, there's another explosion. Most of our brain growth, of our neural development, happens between the age of 0 and 5, where we get most of, you know, we learn to run, we learn to walk, we learn to talk, we learn a lot of very complex things. However, that tends to really exponentially increase those abilities. They tend to level off for a while. You have when your pituitary gland starts to kick in your hormones, we've discovered another explosion of brain growth in the frontal lobe when about 13, 14, 15, when puberty kicks in. And a lot of that has to do with sophisticated social interaction. It has to do with higher learning, reasoning ability, being less egocentric, understanding the perspectives of others. There's another explosion right then. And so many times when we're treating someone with an addiction, that's about the age of onset. Does anybody know the average age in, well, I'll use Garfield County. I'm sorry that leaves the Ponca City and Alva folks out. I don't know the average age of your county. The average age of first intake of alcohol in Garfield County.
Dang, I gotta remember that. 10, 9.
You hit pretty close. Wait, any other guesses?
I'm going off of intake of marijuana, and then I realized that was marijuana, and so I lowered that, thinking the alcohol was probably a little more accessible.
It-
9-ish.
I say at 9.
9?
They start in,
Okay.
is it middle school or, I don't know how you call those schools, but it's 8 to 9.
That's pretty
As
close.
far as I get.
Average age is actually 11. I actually overshot that. I had suspected maybe 14. I was way off. So yeah, it's actually relatively young. So if you had someone develop a substance use disorder at a very young age, you are going to see some impairment into adulthood, and that's just kind of the way it is. There's some critical periods. Now, there's a lot of research that indicates that our brain keeps developing until we're 25, 30. But again, because of the way that we're wired, like that rooting reflex, that's just there. And so biologically, some of these things are just timed to happen, like the eyesight. And so what happens when someone presents with all this damage to their neural network? That's where we come in. And we really can make a difference because our sophisticated technologies are allowing us to go in and see where, okay, there's some damage here, but we've created some new growth and we've created some positive growth. So sometimes your folks are going to present with some very significant dysfunction. We're hopeful that that dysfunction is minimized. Everybody copes with things in a different way, so they're going to have some strengths to build on. But hopefully, we're going to be able to, make a very positive change. So that leads to the question and our understanding of addiction. Why do drugs work?
They alter the way your brain functions.
Yes.
Or the way your body, yeah.
Absolutely. On the most basic fundamental level, they alter the way your brain functions. This is what is in control of us right now, and so that's altering. That's altered. Absolutely. They mimic or alter natural brain processes. So, if you think about that, it's not something that's going on foreign. It's something that's kind of indigenous. If you ingest a substance that's having a psychotropic effect, it's mimicking something that's already there in your body. For instance, I use the example, if I had a ficus tree right here, and I took a leaf and ate that ficus leaf, what's that going to do to me? Might make me sick or something. It's probably not going to make me hallucinate. It's probably not going to give me a lot of energy. It's probably just going to be, it's a ficus leaf. Now if I had a marijuana plant right here, and I ingested a part of that, that's going to have an effect on me because there's a chemical in that's like a chemical that's already in me. So that's what drugs do. That's how they work. So to figure out how they work, we first have to figure out how the brain works naturally. And so I'm going to condense 9 weeks of biopsychology, neuropsychology into hopefully about 30 minutes right here. So you'll get the big picture. So we already have covered a lot of this stuff. We've already covered the separation of function, the thinking part of your brain, and the brain stem, which is the automatic part of your brain. Got the heart, the lungs, and the stomach down there. There is a basic separation of function. Our reptilian brain is basic stuff. Our cerebral cortex is thinking, reasoning, senses, judgment, values, personality, movement, all those good things. Things that we can control. What does the brainstem control? The involuntary stuff. Breathing, heartbeat. I just blinked. I wasn't thinking about it until I read my read the PowerPoint. Oh yeah, I'm blinking, and now I can control that too. Sex drive, digestion, sleep, all that stuff is automatic. We don't have to think about if we're hungry, we just know it. We don't have to think about if we're tired, we just feel it. Automatic things. Already went into the normal cell, doesn't need to communicate. Brain cells are complicated. They have to communicate with one another. So there's a picture of some neurons, electron microscope. How many number of brain cells? Here's your first quiz. How many number of neurons in your central nervous system?
Over a billion.
Yes, over 1 billion. Definitely over 1
Is
billion.
it 100 billion?
Yes, all right, Sonia, $64,000 winner.
Let's share the money.
Does it still count if I wrote it down?
Absolutely, absolutely.
Okay.
It's all about recall, being able to recall.
Okay.
So yes, there are 100 billion neurons in your neural network. Now this is an old PowerPoint. I've made this
I was
over.
gonna say, I thought you said it was 50.
We used to have an understanding of it being 5,000. And so if you just do that math, what if you do 100 billion times 5,000? What does that come out to? I'll show you the number.
Wow.
That comes out to 500 trillion connections. Places where your brain, that's just with 5,000. So if you add another zero, I don't even know where you go after trillion. So this is what's on top of your shoulders is the most complex thing that we know about as humans. You have something very special in your brain. If you had a person and their only job was to go through and disconnect each place where there was a connection in your brain based on the 5,000 number, and he was able, and that person was able to do it at a rate of 1 connection per second. It would take that person 25,000 years to disconnect your brain. So when we have pharmaceuticals, when we have drugs like Zoloft, Paxil, Wellbutrin, Effexor, and you talk about side effects, the reason we have side effects is because we only have a certain number of chemicals. We don't have 500 trillion chemicals at work. When I was in undergraduate school, we knew of 55 chemicals. So when you take a serotonin, selective serotonin reuptake inhibitor, an SSRI, it's selecting some serotonin, not all the serotonin in your brain, because some of the serotonin is doing other things. The chemicals have to do multiple things in your brain. But it still has side effects. You know, every drug is going to have side effects because we're not that sophisticated to go in and manipulate. Oh, I'm going to manipulate 47,432 of these connections that are. We can't do that. So all of your drugs you're never going to have the miracle drug that's just going to do the one thing you want it to do. You're always going to have side effects. I'm always a little hesitant. I agree with using medications when we have to. I'm always trying to help that person recover with their own internal strengths, if possible. Now, if it's a condition of safety, if a person's suicidal, I'm not against. If it can make it very difficult, if a person's been resistant to therapy, I'm all for. But if we can try to make this difference because we have the evidence that we can through our therapy techniques, I try to do it that way. So, how do our neurons work? To understand addiction, we have to understand first how our neurons work. So there's a couple of neurons together. What's this person about to do?
Shock therapy or something?
Hopefully not in ECT. I'm not down with ECT from this guy.
Have their heart restarted.
What's that, Lauren?
Have their heart restarted.
Yes.
Or shocked into a
Different pattern. Yeah, you're in a bad way if you look up and you see this guy. I don't want to ever see that. Because you're getting ready to get shocked, your heart stopped or something's wrong with it. So the reason why is that person going to send electricity through to your heart?
To tell your brain to, I guess to send messages to your brain to tell your heart to start beating.
Oh, that's the best answer ever. Yes, I've asked that question hundreds of times, and that's like the most, you got like multiple bonus questions today. All right, so multiple bonus points. Yes, we don't have time. This guy does not have time to cut into your brainstem, go to your medulla oblongata, which controlling your heartbeat and your breathing and finding the exact neurons that he needs to stimulate. He is doing it the reverse way. He's sending electricity because you are getting electrical signal going from your neurons to your heart that's keeping it pumping. Anybody know anybody with a pacemaker?
Yes.
Yes. Yes, that's the same premise of that pacemaker. Stimulate. We run on electricity. It's why if I got struck by that lightning bolt, I'm going to be much different after I got struck by the lightning bolt.
It's true. I worked with a guy whose daughter got struck by lightning while she was playing a soccer game. And she was in high school at the time, and she lived, but it affected her ability to her short-term.
Short-term memory?
Like she had to have a map to go to her classes.
Really?
She couldn't remember how to get to each class. So basically somebody would help her from each class get to the next class because she couldn't remember how to get to each class every day. And the other odd thing was that she would have to be reminded to eat because she never felt hungry. So she
Whoa.
would have to be reminded to eat, but also once she started eating,
She
she would
didn't
eat
know to
everything
stop.
on the plate. So you had to have portion
Wow.
it so that's what she was going to eat because she would eat everything on the plate. She also didn't feel hungry. She didn't feel hungry, but she didn't feel full. So
That's amazing. I knew a person that I graduated with that got shocked on the campus of Oklahoma State, and he had stroke-like symptoms, like he had some paralysis, but I've not heard, but that's very real. It impairs, if it took out some neural circuitry, it was the part of the brain that makes a person feel hungry or satiated. That's bizarre. But yeah, it's obviously if you throw that much electricity into somebody, you're bound to get some strange results. That's why I don't want to stick a fork into the electrical outlet down there. We're running on electricity right now. It's what's compelling our thoughts. It's what's driving our thoughts. But at the same time, there are also chemicals that are being released. So we work on an electrochemical process. I can't remember this video, but I'll certainly watch it. I should have embedded it, but surely it'll work. There used to be sound that went with this. Try this. Oh.
Can you scroll over, is the sound at the bottom? When you did something that popped up, is the sound down there? Can you adjust it from down there or no? It's on mute. Well, it said unmute when you clicked
Maybe it's the sound on the
computer.
device itself.
Yeah, no, I've got that. I've got that turned on. I think what I was going to say here with that is the cerebral cortex is actually only a 1/4 inch thick. We think about our cortex, as that big mass of all those, looks like worms and all these massive wrinkles. Actually, our cerebral cortex is very, very thin. So when we think about evolutionarily speaking, about how advanced we are from all of our other species around us, actually we're about a 1/4 inch away from them in evolutionary terms. And so it's basically showing some neural networks there. Let's see. And what it's showing is on a very basic level, you know, what it looks like when the electrical signals get sent to other neurons. So these are actually action potentials. If you're in a neuropsych class, this is actually looking at a new connection.
So the cerebral cortex, and is that the
That's the outermost layer.
And so, being that that's the outermost layer and it's that thin, but the inside of our skull itself isn't necessarily, I mean,
Our
we
brain.
have some fluid, but isn't it pretty, if you get bumped hard enough, it's not like, I mean, bones are kind of pointy as I've understood. I mean, it's not like,
And so
I'm saying, what I'm saying, I guess, is that our bone, our skull itself has the potential to just
injure our brain.
injure our brain.
Absolutely.
Because it's not like
That's what a concussion is.
Yeah,
So
it's
if
not
I were going ahead,
soft and fluffy in
like,
there.
because our brains are actually floating a little bit.
Right,
So
so it gets banged.
if I'm going 20 miles an hour this way and it comes to a sudden stop, might just be just like if you're in that car going 20 miles an hour, that seatbelt catches you.
Right.
Sometimes people get a big bruise when they're in a wreck because
But isn't our brain not exactly even just smooth in there? I mean, our skull is not exactly
No.
smooth in there either, so.
okay, I see what you're
You
saying.
know what I'm saying? It's,
Yeah.
so not only does it get bumped because it's not that far away from it, but
Yeah,
it's not exactly
you have
smooth either.
ridges and
Wait, not the
Yeah.
brain part, I'm sorry, the skull part.
skull inside, yeah. So what the video is illustrating is the action potential, the electrical impulse actually hitting this. Now none of those 500 trillion connections, those are actually gaps. Those cells don't actually touch. There's actually a synapse, a gap in between. So if they all were always connected, we wouldn't be able to do anything because we'd just be completely stimulated. So we need to have like an off and on switch with each one of them. So this is kind of showing that process right there. So you have little chemicals in that presynaptic neuron, and they get released, and then what happens is the postsynaptic neuron down here catches the chemicals, and it starts the electrical signal all over again. So that's what that is illustrating. I'm sorry there's no sound. You're welcome to use the link on YouTube to find a way to get sound. But it's incredibly complex. This is happening at, billions upon billions of times per second as we're sitting here. There's a process that's called myelinization that makes this more efficient. It's when your axon becomes myelinated, where if you learn a new skill, has anybody ever dreamt about something that they've learned or did in a previous day? Raise your hand. Or about the next day, something that you're about ready to do. That is actually your brain getting prepared and learning. They did an experiment where they took people, and they were actually young people, and they taught them a new skill. They had them do a computer activity, and so one of the subjects, and they spent the same amount of time doing it, relatively same IQ. The experimental group, they had the person get sleep deprived, but not completely sleep deprived. Whenever they were going to dream, let's say they went to sleep, they would get woken up once they entered REM, the dreaming state. They let them sleep otherwise. The other person they let just go ahead and sleep. The next day, they came back, and for every subject they did that with, there was a very significant increase in the ability to reproduce the skill that they learned the day before versus the person that didn't get REM sleep, that didn't get REM sleep. So your brain is actually very quickly modifying itself. Sleep and dreaming is a very, very important restorative time for humans. So when we're talking about folks that are going through times when they're not sleeping, they're waking up in the middle of the night, let's say, and also substances, chemicals, oftentimes impair the ability to dream. An alcoholic, somebody that smokes a lot of marijuana, both of those chemicals impair the REM stage. They inhibit REM sleep. And so those people, although they may be sleeping, they're not getting restorative sleep. They're not getting that reinforcement. So that's something else to remember when you're treating people. How one of the good ways we can help a person with depression is restoring that REM sleep and their own restoring their own neuroplasticity, their brain's ability to heal and change and adapt by letting them and empowering them to sleep. So that's something else to consider as you work with people. So again,